That is very, very, very tentative. I was looking over pacing, I was looking over the chapter, and I don't like how it's paced or how it's presented, so I'm going to change stuff. I might pull stuff out, so one day we're supposed to be doing something, I might throw something in, or I might just stop at some point and switch it around. So that is very, very tentative right now. What that gives us, though, for those of us that are going to be here for the test, this will be our last test regardless of what's on it. This will be our last test, and whatever material we cover after could still be on the final, but I won't have a test for it. Okay, not that you guys can. You're just like, yeah, test them. I don't care. Have more tests. As long as we're not taking a test by Tuesday, I'm okay. That being said, seniors, do your homework. Do what's expected of you in class. It is still expected that you know this for next year if you do calculus or something. All right? So do your homework. Stay on top of stuff. Don't just slack and just sleep through class for the next week and 2 days. All right. Our first section is on sequences. And we should have covered sequences already in Algebra 2. So most of this should be kind of a review. So I'm going to throw a whole bunch of things in different sections. So if you're stuck or you don't remember how to do it, ask questions. All right? Don't just sit there and go, oh, I should know this. Oh, well, I don't. I'll figure it out on the test. All right? Ask questions today because I'm going to rifle through a whole bunch of material. So we're going to start off with what is a sequence. A sequence is just an ordered list of numbers. All right? An ordered list of numbers. So this is a sequence. 4, 5, 6, 7, 8, 9. It's also called, this one is an infinite series or an infinite sequence because this ... tells you it just keeps going on forever. Sequences can end. I could just cover up the ... and that would make it a finite sequence. So finite has a start and an end point. Infinite can either go on infinitely that way, it could go infinitely that way, or it could go infinitely in both directions. So I could put a ... here and say I don't even know where it starts. I just know this little section, I don't know where it ends. Okay? So infinite goes on forever in either direction or both. A finite has a starting point and an end point. All right, when we're dealing with sequences, it's often good to know which term I'm talking about. So I can say like the fifth term, rather than having to say 8 or 7. So when we're dealing with sequences, we talk about terms a lot. We'll see if this one works. This one does not write. We talk about terms. And they're just ordered like you would anything else. Our 4 would be our first term. I need a new stylist. Our 4 would be our first term. This would be our second term. This would be our third term. 4th, 5th, 6th, 7th, 8th, 9th, 10th. Now another way we can describe terms is we're going to use a notation that uses a sub numbers. So we're going to use a notation that deals with a sub something. So we're going to put an A there, and A sub 1 stands for our very first term. So whatever number's here is telling me what term I'm looking for. So if that's my first term, my second term would be A sub 2. My third term would be A sub 3, and we would continue on from there. So that's another way we can list it. The last way we can list what order things come in is we can do n equals. And for our first term it would be 1. For our second term it would be 2. For our third term it would be 3. So any one of these methods can be used to show me which term I'm talking about. So I can either say first term, I can say A sub 1, or I can say where my n equals 1. Where A sub, right, A sub 1, the 1 matches up, the 2 matches up, the 3 matches up. So that means if I would continue on, I can go A sub n, just any term, which would match up with my n here. Okay, that's just a little bit of notation. Now, using that A sub n, so if I'm using A sub n, and I'm saying it's some term. All right, a sub n is some term. Then a sub n minus 1 is going to be the previous term. This is going to be my previous term. Because I'm taking the term that I'm at, and I'm going to subtract 1 from it. All right, an example of this might be, let's say I have a sub 3. I start with a sub 3. All right, then a sub n minus 1 would be a sub 3 minus 1, which would be a sub 2, which is the term back. Right, term 3, the term before it is 2. So this stands for the term before it. The term before it. That must mean that n minus 3 is 3 terms before it. All right, because I have n minus 3. It says take your term. So if I'm on the third term, I would go 3 steps back. So this is 3 terms prior. 3 terms, let's just say before. So once again, if my n is a sub 3, bless you, we would have a sub 3 minus 3, which equals a sub 0, which is definitely possible. A sub 0 can be a starting point. All right, a lot of times formulas will use a sub 0 as your starting off point because that's your jump off point, and a sub 1 is the first time something happened to it. So you'll oftentimes see an a sub 0 is your very first term. For me, and in this class, I'm going to stick generally with a sub 1 as being your first term. But I don't want to get thrown if you ever see a sub 0. This is possible. It's just the term before this one. All right. All right, so that is possible. So that's 3 terms before. Can anyone make a guess what a sub n plus 5 would be? Yeah, Chris.
5 terms after.
5 terms after. Perfect. So 5 terms after a sub 3 is going to be a sub 8. So if I start with the third term, I add 5 terms to it, I must be on the 8th term. And I think the easiest way to use this notation is to start talking in that manner, where this is the term before, this is 3 terms before, this is 5 terms after. It's easier to talk that way because it's a lot easier to actually do the math then, versus going, oh, if I add 5 to 3, that 8, that is my 8th term, that is, versus me just saying it's 5 terms after what I'm talking about. All right, we have 2 different ways to write sequences. Well, 2 major ways. There's other ways to do it, but these are the 2 major ways. And that is recursively and explicitly. Recursively and explicitly. So the first one we're going to talk about is recursive. A recursive formula is a sequence in which each term is based on the preceding term. So you must know all of the terms before the term, I guess, that you're looking for. In other words, if I'm looking for what is the 100th term in this sequence, you would have to know all 99 numbers before it. So recursive can get very time-consuming because you have to do every single step. So this one says write the first 5 terms. So first of all, I just want to note that this stands for, hey, that's my first term. So how I read this statement here is my first term is -2. That's how you read that in plain English. How I'd read this one is the term I want equals n plus the term before it. So the term I want is n plus the term before it. So the big takeaway is that this is the term prior, the previous term. So it says find the first 5 terms. Well, they already gave me the first one. So a sub 1 equals -2. You can either rewrite it or just leave it up there. My second term, so the term I want is going to be whatever that n is. My n is 2, so we're going to put 2 here. Then we're going to add the previous term. Well, the previous term was negative 2. So we throw that in there. And that's going to equal 0. A sub 3 is my third term. My third term is going to be that n value, which is 3, plus the term before it, which is 0, which equals 3. Our fourth term is going to be 4 plus the term before it, which is 3, equals 7. Finally, our fifth term is going to be 5 plus the term before it, which is 7, which equals 12. Now just remember, recursive, I need to find every single one of them to build up. All right, so like I said, if I asked for the 100th term using recursive, it would be a long, long problem. All right, we're going to do one more of these. So remember, this says that the first term is negative 1. My second term is 1. My sequence is going to be 2 terms prior plus 3 times the term before it. So sometimes we can go way up in that list. So I'm going to make, so this is my first term is negative 1. My second term is 1. My third term is going to equal 2 terms prior. So that's that negative 1. Right? That's that negative 1. What I could also put on here is I could say 2 terms prior is a sub 1 plus 3 times a sub 2. So you can do the math. You can plug a 3 in and say 3 minus 2 is 1, a sub 1. 3 minus 1 is 2, so it's a sub 2. So that's going to equal a sub 1 is negative 1. Plus 3 times a sub 2 is 1. So that's going to equal 2. All right, so you can just plug in your n's. So your 3 is going to go in for your 2 missing n's. Or you can just say it out loud that a sub 4 is 2 prior. So that's going to be that 1, because 2 prior is that 1. Plus 3 times the 1 before it, which is that 2. And that's going to equal 7. And finally, our fifth one is 2 terms prior is 3, so that equals 2, because a sub 3 equals 2. Plus 3 times the previous term, which was 7, which equals 23. All right, any questions on writing those terms? So you have 2 methods. You can either just plug this number in for your n's and figure out which ones match up, or just say it in plain English. This is 2 terms prior. This is 1 term prior. This is 3 terms prior, and just look at what is my third term prior, what is my second term, what is my previous term, and just write it that way. Okay, like I said, recursive formula can be tedious because you have to know everything before it. That's why more often than not we try to find an explicit formula or some kind of pattern to all these. So the explicit formula is a sequence in which each term is based as a function of its n or placement in the sequence. So it works just like a regular function, where we have n's in here, we just got to figure out what number goes in there, and then we go from there. So the note with explicit is it's not based on previous, not based on previous terms. So it allows us, if I wanted to find the 100th term, I could do it really simply. So we're supposed to write the first 5 terms. Note that we don't have any a sub n's on this side. It's just n squared plus 1. So we take whatever number's here, plug it in for that n, and that is what we got. So if I'm finding my first term, a sub 1, I'm just going to take that 1, plug it in for that n. I don't know why I changed to purple. Let's go back to black. Plug it in for that n, and it's 1 squared plus 1, which equals 2. I know it says find the first 5 terms, but I'm going to skip. I'm going to show you that we can just skip. So I could go ahead and find the third term. It's going to work the same way. I'm just going to take that 3 and plug it in for my n. So I have 3 squared plus 1, which is going to be 9 plus 1, which is 10. And let's go ahead and skip to the fifth term. So that's going to be 5 squared plus 1, which equals 26. We cannot do that with recursive. I have to find every single one of them along the way. When it's explicit, I can jump around. So I can find the 100th term easy peasy. That's a short problem. Finding the 100th term on this one, that's a long, drawn-out process. All right, I did this next one as a prime example of, do you see this negative 1 to the n minus 1? Well, negative 1 to the 0th power is a positive 1. Negative 1 to the first power is negative 1. Negative 1 squared is a positive 1. Negative 1 cubed is a negative 1. So all that's doing out there is it's alternating between positive and negative. So it's just going positive, negative, positive, negative. So the only point of this being here is to alternate between positive and negative. So this just alternates between negative and positive. So realistically, we just have to figure out where the pattern starts. So if our first one is positive, that means I know the next one's negative, positive, so forth. If our first one's negative, then it goes positive, negative. So realistically, all I need to do is find the very first value of this, whether it's positive or negative, and I have everything this thing's going to do later on. So we're going to go ahead and write the first 5 terms. We probably won't write all 5, but we'll go a sub 1 is going to equal negative 1 to the 1 minus 1 times 1 cubed plus 1. Well, 1 minus 1 is 0, so negative 1 to the 0th power. What's anything to the 0th power? 1. Positive, right? Positive 1. So that means that we have a positive out front. And 1 cubed is 1 plus 1 is going to be 2. So we have a positive 2. That means, assuming that my assumption is correct, the next one should be negative. All right, let's check to make sure that's true. So if I do a sub 2, that's going to be negative 1 to the 2 minus 1 times 2 cubed plus 1 is going to equal, that's negative 1 to the first. Yeah, that's negative. That guy's negative. And we have 2 cubed, which is 8, plus 1 is 9. I'm going to skip a to the third. Let's go to a to the fourth. So that's negative 1 to the 4 minus 1 times 4 cubed plus 1. So if I followed this pattern, positive, negative, positive, this should be negative. Negative 1, 4, that's the third. Yep, it is negative. It is negative. 4 cubed is 16 times 4, which is going to be 64, plus 1 is 65. So all I know is that this is positive, negative, positive, and I think you could do the rest from there. So you could fill in those 2 blanks. I'll let you fill in those 2 blanks. Any questions on that? So the big takeaway from this one is that alternating between negative and positive. because you will have to come up with your own explicit formulas. And as soon as you see them alternating, you should immediately think of that negative 1 to the n minus 1. N plus 1 also works, and so does negative 1 to the n. Each one serves a little bit of different purpose, but they all alternate. It just depends on whether you want a negative as your first value or a positive. So if this would have been negative to the nth power, this would have been negative to start off with. All right, so don't assume it's always positive, negative, positive, negative. It can be negative, positive, negative, positive. Check that first one. And this is how I do it. I check the first one, and then I kind of do the alternating, and then I check my very last one I have to do. So if you check your first one, you check your last one, and they both work, then your middle should be right as well. Okay, writing formulas for the general term, or our explicit form. So all we have to do is recognize patterns, and this gets a lot easier. Today we're just kind of working on intuition, but tomorrow and so forth, we're going to come up with easier ways to come up with these patterns. But the first thing we're going to do is we're going to look for a pattern. And if I look at from 6 to 8, well, I add 2. From 8 to 10, I add 2. From 10 to 12, I add 2. And I'm just going to note my term numbers. So I'll put n equals, this is my first one, this is my second term, this is my third term, this is my fourth term, and it would go on from there. So all we're doing is we're adding 2, adding 2, adding 2, adding 2. What I'm going to do is I'm going to write out this pattern using 6 as my first term. That's my starting out term. Then my second term is going to be 6 plus 2, because I just added it. That was my first step, is just add 2 to it. My third term is going to be 6 plus 2, but then I add 2 more to it. Well, another way I could rewrite that is just 6 plus 2 times 2. My fourth one was 6 plus 2 plus 2 plus 2, because that gives me 12. Well, that just equals 6 plus 2 times 3. Well, working this pattern backwards, I have 3, I have 2, so this one should be 1. This one should be plus 0 2's. So 6 plus 2 plus 2 plus 2 gives me this term, or 3 2's. So we have a nice pattern here. It goes 3, 2, 1, 0. But the 6 and the 2 stay the same. So now I'm going to go ahead and I'm going to write my formula. So we have a sub n equals, I know it's 6 plus 2, and that 2 is going to be multiplied by something. That something is going to be dictated by, yeah.
So can I say it?
Yeah, absolutely.
Minus 1?
It's going to be n minus 1. Yep. Because this one needs to be 0, 2 needs to become 1, 3 needs to become 2, 4 needs to become 3, so we just subtract 1 from it, so it's going to be n minus 1. And rather than make you do this every single time, I'm going to skip to tomorrow's lesson really quick. That makes this a little easier. If I go ahead and distribute this 2 out, so I have 2n minus 2, and I'd rewrite it. And I rewrite it. We note that we can rewrite this as 2n plus 4. All right, it's just I expanded it. That's a linear equation, isn't it? That's a linear, like 2x plus 5, mx plus b. This is just a linear equation. It's a linear equation. And the slope equals 2. Well, it's no coincidence that the slope equals 2 And our pattern just happened to be adding 2. That is no coincidence. And in fact, this is going to work every single time. Every time you realize that it's adding or subtracting by a number, we're going to jump right to that. And that's the example we're going to do right here. This is an old copy that I didn't save apparently. But we're going to go down to that bottom right corner, because this is going to be the exact type of example. So we have 7, 13, 19, and 25. Once again, this is my first term, so I put n equals 1, 2, 3, 4. To get from 7 to 13, I add 6. I add 6. I add 6. So whenever we're just adding or subtracting, we're going to immediately note that it's linear. And tomorrow we're going to give it a different name, but for right now we're just going to know it's linear. So that means we're going to have a sub n is going to equal, we're going to carry down that 6, that positive 6, and we'll attach an n to it. So it's something 6n. Note on the one before it, we had to have 2n plus 4, so I need to figure out what that number we're going to add to it. In order to do that, we're just going to check one of them. Well, a sub 1 equals 6 times 1, which would give me 6. It's supposed to come out as 7, so we're just going to go ahead and add 1 to it. Plug that guy in here and that. So we're supposed to equal 7, and it does now, so we just add 1, and that is our equation, 6n plus 1. Now I'm just going to check one of them. My third term is supposed to be 19, so if I replace this n with 3, 6 times 3 is 18, plus 1 gives me 19. It works out, and it'll work out for all of them. Okay, let's go back up to that top right one. So if I was on that adding kick, I want to see if they add together or subtract. So this one I could add 2 over and over and I'll be good. On top, if I added 2, I get to 4. But if I added 2, I don't get to 8. If I add 2 to it, I don't get to 16. So it's not adding 2. What pattern's on the top?
Just like go up by like,
Yeah.
like square root and then not square root, like squared to or to the it's like 2 to the second is 4, 3 to the second, or 2 to the
Yeah, I got you. We could do powers, or we could,
powers.
either one will get to the same answer. I'm going to look at the multiplying, like he said. But yours is good. Yours will work too. I just have it set up as, rather than adding, I'd multiply by 2. I'd multiply by 2. I'd multiply by 2. But that's exactly what Mike said. Mike said that this is basically 2 to the first, 2 squared, 2 to the fourth, or 2 to the third, 2 to the fourth. Our bottom one, that's not supposed to be a 4, it's supposed to be a 3. Because otherwise this one doesn't work out. Because this one's going to be times 3, times 3, times 3. Mike already kind of said what we're going to have here. We are going to have, if you multiply instead of adding, it's going to be an exponential formula. That will tell you it's exponential. So multiplying by 2 tells me it's exponential as well. So both of those are going to be exponential. So on the bottom, or on the top, we're going to have a sub n is going to equal 2 to some power. I don't know what it is yet. We'll figure it out in a second. And on the bottom, it's going to be 3 to some power as well. So whatever this multiplication is, that's going to be my base of my exponential function. Now I just got to figure out what goes in here. Yeah? N minus 1. Well, if it's n minus 1 for our first term, that would be 1 minus 1, which would be 0. You're close, though.
Yeah, starting at 2.
Instead of n minus 1, it's going to be... You sure? N minus 1 is close. Yeah, if we start at 2, that would work. But what if we're starting at 1? So let's just do a sub 1 equals, yeah,
Would it be n minus 1, and then,
plus 1. So what's n minus 1 plus 1?
so in this case, it would be
Simplify.
minus 1 is going to be 0. Wait, that doesn't work.
No, stick with what you said. Stick with what you said. So you said it's n minus 1 plus 1, right?
Yeah. So, it
I'm
would
okay.
be n.
It would just be n. It would just be n, because a to the 1 would be 1, 1, so that'd be 2 over 3. So this is just going to be 2 to the n minus 1 plus, or just n, and 3 to the n. So just look at your first term. Your first term is going to tell you what this value needs to be. Sometimes it will be n minus 1, sometimes it will be n plus 1, sometimes it will just be n. Okay? So for ours, we're just going to always assume we're starting at n equals 1. Because Mike was going down a path where he was saying, what if I start at 2? And that's okay, Mike, because you said that. You said, what if I start at 2 instead of 1? That works too. You just have to tell me you did that. Okay, so if you did 2 to the n minus 1 and say n equals 2 to start off with or something. Okay? Alright, next one. We have a whole bunch of fractions, so I'm going to probably turn this 1 into 1 over 1. I'm also going to note that it's alternating between negative and positive. So since it's alternating negative to positive, negative and positive, I'm going to need that negative 1 to some power. And I want the very first one to be positive, so that's going to be n minus 1. So to get my alternating negative and positive, you have to use this negative 1 to either the n or the n minus 1. So I took care of that. What's our top going to be? Yeah.
It's going to just be 1.
It's got to be 1, right? Because it's not going to all of a sudden, I'm not going to go 2 over something. So our top is going to stay at 1. So I already got my top. I got my top, I got the positive and negative. So now I just got to get the bottom. Well, if I follow that multiplication thing we did, well, adding's not going to work because plus 3 plus 3 plus 3, that doesn't work. Multiplying doesn't work. 1 times 4 gives me 4. 4 times 4 gives me not 9. 9 times 4 doesn't give me, so I can't multiply by 4. So the last trick we can kind of do is we can jump right to what Mike did on the last one and look at how can I break down these numbers. Well, I can rewrite 4 as 2 squared. I can rewrite 9 as 3 cubed. I can rewrite 3 squared. Got it. And we can rewrite 16 as 4 squared. So if my n is 1, that is 1 squared. So let's put all of this together, what we know, to get our bottom. Our bottom is going to equal something squared. And now we just have to figure out, is it n plus 1? Is it n? Is it n minus 1? Is it n minus 3? What would be our base on this one? Yeah.
Would it be n squared?
It would just be n squared. And let's check to make sure that works. So if I do my n values up above, this would be my first one. This would be my second one. This would be my third one. This would be my fourth one. Is this one just 1 squared? Yeah. Is this one just 2 squared? Yeah. 3 squared? 4 squared? So it is just n squared. Whatever n I'm on, I just square the bottom. So our complete thing is going to be a sub n equals, don't forget about that negative 1 n minus 1 times 1 over n squared. Or you can write it as a sub n equals negative 1 over n minus 1 over n squared. Either one of those work. All right, the last thing I want to talk about are factorials. So like I said, we're running through a bunch of material. Is factorials. Factorials are, you just take your number, so if I have 9 factorial, it's just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1. So you stop at 1. The big key from this definition you need to have memorized or know is that 0 factorial equals 1. 0 factorial equals 1. It's the one you can't really do by hand. If you plug it in your calculator, you'll come up with 1 as well. All right, I'm going to run down that right side. So each of these can be done using paper, not your calculator. And the way we're going to do that is we're going to write them out. So I'm going to write out 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's going to be over, well, 2 factorial is 2 times 1, and we're multiplying that by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Well, a number divided by itself is 1. So if you look at this 6, 5, 4, 3, 2, 1, that's the exact same number as 6 times 5 times 4 times 3 times 1. So those are just going to turn into 1, or we're just not going to deal with them because we're multiplying by 1 on top and bottom. So that means it's just 8 times 7, which is 56, divided by 2, which is just 28. All right, do the same thing for the next one. I have 2 factorial on top, so that's just 2 times 1. We're going to multiply that by 6 times 5 times 4 times 3 times 2 times 1. And on bottom I have 3 factorial, which is 3 times 2 times 1. And I'll multiply that by 5 times 4 times 3 times 2 times 1. So once again, I'm going to note I have this 5, 4, 3, 2, 1 there. I have this 5, 4, 3, 2, 1 there, so I can get rid of those. I also have this 2 times 1, and I have this 2 times, I should do that in a different color. Let's do blue. So I have 2 times 1 here. I have 2 times 1 there. So those are going to cancel out. Well, it'll turn to 1. And so all we really have left is 6 divided by 3, which equals 2. When we get good at these will be a lot quicker because I won't have to write everything out. I'll know that the 6 factorial cancels out with that 5 factorial. We're going to do that with n's. So writing the top one, I'm going to have n plus 1 times n plus 1 minus 1. So that's going to be n, because I'm 1 less. Now my next one is going to be n minus 1 times n minus 2 times n minus 3 times n minus 4, and we continue on and on. And that's going to be all over n factorial, which is n times n minus 1, because it's 1 less than n, times n minus 1, which is n minus 2. And we'd continue that pattern. But once again, I want you to note the stuff that's just going to become 1. Well, that's all of this. That's going to turn to 1. And so all we're left with is n plus 1. All right, just for time's sake, we're not going to do all of these. We're just going to start with the first one. So we're listing the first 5 terms of a sub n equals negative 1 to the nth power and over n minus 1. Remember that negative 1 to some power is just alternating positive and negative. We just got to figure out what's the first one. Is the first one negative or is it positive? So a sub 1 is going to equal negative 1 to the first power all over 1 minus 1 factorial. Well, negative 1 to the first power is negative. So we have a negative out front, and then it's 1 over 0 factorial. 0 factorial is 1, so this just equals a negative 1. I'm going to skip a couple, so our second one is going to be positive then. If our first one's negative, our next one's positive. Our third one is going to be negative. I'm going to skip to the fourth one. We're going to do the fourth one. All right, fourth one is, it should be positive. So we do have negative 1 to the fourth power, all over 4 minus 1 factorial. Yeah, negative 1 to the fourth is positive, so we're good on the positive aspect. So it should be positive. And then it's going to be 1 over 3 factorial, which is just going to equal 1 over 3 times 2 times 1, which equals 1 over 6. And it is a positive 1 over 6. And we do the same thing for the fifth one, the third one, and the second one. All right, I do want to note that the homework is not out of the book. These are problems I put on there. So that means the solution key is not going to be in the solution key manual. Where it's going to be instead is in that blank lessons, where you go to find your blank lessons. I have the blank lesson and I have the answer key right above it or below it, depending on how you have it organized in there by name or date. Okay, so that is where your answer key is. Get them done. There's not that many, but